Hey, sixth graders in regular math class with Miss Garrett. This is Miss Goff. And what I have done for you guys, I know there's been a lot of disruptions and things going on this week. So, what I did is I went through and made a practice quiz. It's not for a grade, but here's what I think you guys should do. You should probably follow along, do the questions with me, and it'll give you kind of an idea of what to expect when you get to the quiz, which you will do right after this. And you should be able to use your resources, your papers and things in your binder. And so this can be another resource for you to do. It's not the same questions as the quiz, but it kind of gives you some practice. Okay. So we're going to walk through this together. So the question number one, it says, what is the value of this expression? Basically, it's saying, simplify this and give me what the answer is. And you guys need to remember your order of operations, which is abbreviated PEMDAS. Which means you need to deal with your parentheses first, then your exponents, then you can do multiplication and division, and you save addition and subtraction for last. Okay, so looking at this one, I'm actually going to do my parentheses first, and that is -2 plus 4. And I've already seen some of y'all have some issues with this addition, so I'm just going to make a little number line down here. Here's 0. -2 is over here, okay? And if I add 4, that means I'm going to go this way 4 times, okay? So I'm at -2 and I hop 1, 2, 3, 4 spots and I wind up here. And that's at +2, okay? So the answer from the parentheses is actually 2, not -2. You started at -2, but then you added 4 and you got to +2. Okay, so I'm going to show you what we've got after that one step. I haven't done anything up here with the numerator yet. Oops. And I expect you, if this is going to help you at all, you really need to be writing all of this down. Okay, so this is what we have after one step. I dealt with parentheses. Now I'm going to deal with exponents. This is an exponent. That means 5 multiplied by itself twice. 5 times 5. Okay? And hopefully you know your multiplication tables. 5 times 5 gives you 25. So after that one step, here's what I have. Okay? Oops. Going off the page a little bit. All of that divided by 2. All right. So now I have 25 minus 3 times 10 plus 11. Even though it's tempting to do this subtraction because we like to read from left to right, so some of y'all have tried to just be like, oh, I'm going to do my math from left to right. You can't do that. You have to follow the order of operations, okay? So we did parentheses, then we did exponents, and then we've got to deal with multiplication and division. Okay, so here we've got to multiply. Okay, 3 times 10 is 30, but there is a minus sign. Okay, so after this one step, I have 25 minus the 3 times 10, which is 30, plus 11. And again, all of that is going to be over 2. All right. Now, I can't do the division until I get everything in the numerator sorted out and simplified, okay? So if you ever run into a situation like this where you have a division bar, you got to get everything in the numerator taken care of and then get everything in the denominator taken care of, and then you can finally simplify. Okay. So now I'm just down to adding and subtracting here. So I'm going to do 25 minus 30. But Ms. Goff, it says addition before subtraction. These guys are sort of can be done at the same time or, you know, in either order. multiplication, division can be kind of done in either order, but it's got to be parentheses, exponents, then these guys last. All right, 25 minus 30. Like you've got a debit card with $25, you tried to spend 30, you're now at negative $5. Okay, so 25 minus 30 is negative 5 plus 11 over 2. Okay. Now, interestingly enough, I'm going to do a little switcheroo because y'all just learned some of those properties that says, you know what, if I have this plus this, it's the same as this plus this. A negative 5 plus 11 is the same as plus 11 minus 5. Okay. And 11 minus 5 is 6. 6 divided by 2, and you get 3. Now, if I just blew your mind doing that, then don't do that. Think of it this way, and I'm going to use a little bit more real estate over here. Here's your 0. If you're way over here at negative 5, and then you add 11, you're going this way. 1, 2, 3, 4, 5 hops, and I wind up here at a positive 6 after 11 hops, okay? So that's how I get this guy. All right, and then 6 divided by 2. My final answer is 3 for up here, okay? All right, number 2. Let me switch ink colors so that you can see what goes with which problems. And by the way, please pause this if you need to write something down, because you would, it'd be really great if you had all of this information. Okay, so number 2, I'm going to do kind of in this hot pink, and it says which expression does not have the same value as the others. Well, 8 squared. Remember, 8 squared is not 8 times 2. It's 8 multiplied by itself 2 times. I have an 8 and an 8. I have 2 8s, 8 times 8, which is 64. That is not the same as saying 8 times 2. Here, I have 2 squared, which is 2 times 2. And I have 4 squared, which is 4 times 4. Okay. 2 times 2 is 4. And then I say times 4, because this one's this one. Okay. 4 times 4 is 16. 16 times 4, that gives me 64. Okay. So I've got 64 for this one. I got 64 for this one. I'm running out of room, but I'm going to do this one over here. All right, 4 to the third. That doesn't mean 4 times 3. It means 4 multiplied out 3 times. 4 times 4 times 4. 3 4s. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So I'm thinking we're probably going to wind up with D being the one that does not have the same value, but let's just double check. All right, I've got 4 times, this is not 3 times 2, this is 3 multiplied by itself twice. 2 3s, okay, 3 times 3. And then 2 times 2. All right, 4 times 3 is 12. 12 times 3 is 36. 36 times 2 is 72, and 72 times 2 is 144. So the one that does not have the same value is D. Okay, I went over this with one of the classes, but let's just talk about prime numbers. Remember, prime numbers are numbers that are only divisible by 1 and whatever that number is, okay? So for instance, our smallest prime number is 2 because 2 is only divisible by 1 and 2. Then we go up 1. 3 happens to be a prime number also because it's only divisible by 1 and 3. We're not going to write 4 because 4 is, yes, it's divisible by 1 and 4, but it's also divisible by 2 and 2. So, and that's not y'all's bell. So 4 I'm not going to list as a prime number. So go on up another one. 5 is a prime number because it's only divisible by 1 and 5. 6 I'm not going to write down because 6, yes, it's divisible by 1 and 6, but it's also divisible by 2 and 3. So it's not prime. It's a composite number. Okay, then I hit 7. 7 is only divisible by 1 and 7. So I'm going to list it. These are some of my smallest prime numbers. Okay, I'm not going to list 8 because 8, yes, it can be divisible by 1 and 8, but it's also divisible by 2 and 4, etc. Okay, I'm also not going to list 9 because, yes, 9 is divisible by 1 and 9, but it's also divisible by 3 and 3. 10 is not a prime, it's a composite because I can divide it 5 and 2. But I hit 11. 11's a prime number, okay, because it's only divisible by 1 and itself. 12, it's not prime, it's composite because I can divide 12 into 6 and 2. I can divide 12 into 3 and 4. The next prime number I hit is 13. And 14's not prime, 15's not prime, 16's not prime, 17's the next prime number. But anyway, so there's fewer and fewer as we go. Like there's more and more spacing between the prime numbers. But those are some of your smallest ones. Those are what, the 6 smallest prime numbers? I say all that because you need to kind of remind yourself that you're going to have to break this number down all the way until you have nothing left but prime numbers, okay? So I look at 96, and because I know my multiplication tables, I know that 8 times 12 is 96. But neither one of those numbers are prime numbers, so I have got to keep going. I can divide 8 into 2 and 4. And I can divide 12 into 4 and 3. Now, 8 into 2 and 4, 2 is prime. I'm going to circle it, and I can stop dealing with that because that's a prime number. I do have to do something with the 4 because it's not prime. I'll come back to it in a second. 4 is not prime. I've got to deal with that. 3 is prime. I'm going to circle it, and I'm going to stop. 4, I'm going to come back to. 4 can be broken down into 2 times 2. And now both of those are prime because they're 2's. This other 4 can be broken down into 2 and 2. All right. And now I have nothing left but prime numbers. Okay? How many 2's do I have? 1, 2, 3, 4, 5. So the prime factorization is going to be 2 to the 5th because it's going to be 2 multiplied by itself 5 times. 2 times 2 times 2 times 2 times 2 times 3. Okay? Now, do you have to do it into 8 and 12 to get your final answer? No. 96, we could have done, hey, 96 is 2 times 48. And then 48 is, I don't know, 12 times 4. And 12 is 3 times 4. Okay, 3 is prime. And then I break that 4 down into 2 and 2. And I break this 4 down into 2 and 2. But the point is, it doesn't matter really how I break it down as long as I do it properly. 1, 2, 3, 4, 5. I still wind up with 5 2's and a 3. Okay?